Alright, we're going to go ahead and get started with our first lecture video for Unit 3, Chemical Bonding. In this lecture, we're going to look at why chemical bonds form in the first place. To start out, we're going to look at a chemical reaction between sodium metal and chlorine gas. Now, when we take sodium metal and we heat it up and we place it in a jar of chlorine gas, a violent chemical reaction is going to occur. This is going to produce a bright flame and a white solid compound known as sodium chloride. Now to us, sodium chloride is known as table salt, which is the same salt that is found predominantly in our foods and we consume and enjoy very much. All right. Now I have in your study guide here basically the reaction that occurs, and I'm going to go ahead and highlight that in your notes right there. Solid sodium reacts with chlorine gas to produce sodium chloride. Now, we're going to go ahead and take a look at this reaction using a demonstration, live demonstration here. Show you the video. Oh, actually need to back that up. There we go. All right, so what we have here is a jar that's being filled with chlorine gas. The chemist is going to continue to fill it up until it's full. Takes out the gas tube, and he's going to cover the jar that's filled with chlorine gas. You'll notice that the jar has a tint faint yellow color. That's the chlorine gas that's in there. Now he's going to take a jar that has sodium metal in it, and he's going to take a small chunk of that piece, and he's going to place it into another jar that has basically oil in there to keep it from violently reacting with the water in the air. And of course this reaction is very violent, so he's going to make sure he's safe. Now he places the sodium metal in a ladle, which he's then going to take over to the Bunsen burner, and he's going to heat it up to extremely high temperatures in order to get it to melt. Now as you watch the sodium in the burner, you'll see that it's causing a flame test to actually occur, and you can see a kind of that orange-yellow flame caused by the electrons transferring. Now it's melted, so he puts it into the jar with the chlorine, and the reaction occurs. While the reaction is going on, sodium chloride is being formed, which is collecting at the bottom there. Again, you see the bright yellow flame. It's occurring while the reaction is going on. And the reaction is done. So that kind of gives you an idea of this reaction between sodium metal and chlorine gas. Alright, so let's go back to our notes here. So just like lithium, or like sodium and chlorine reacting, most of the elements on the periodic table are going to react to form compounds. So why do they react to form compounds in the first place? Well, this goes into bonding and why chemical bonds form in the first place. So that's what we're going to address right now, but before we do that, we need to define what a chemical bond is. And so in your study guide there, I have a definition for you, and I'm just going to point out or highlight some important points here in your notes. It says the losing, gaining, or sharing valence electron causes an electrostatic attraction between atoms. Now, that electrostatic attraction between atoms is essentially the chemical bond. So this attraction between atoms, hold them together in space, is known as that chemical bond. Now, without this electrostatic attraction between atoms, or the chemical bond, then the chair that you're sitting in right now, or the desk that you're writing at, would just simply fall apart into a pile of individual atoms. All right? So at this point, atoms are now going to come together, and they're going to bond to form compounds, and those compounds are making the more objects that you're familiar with around us. That is a big part of our lives. So why do chemical bonds form in the first place? Why do these atoms get together and bond? Well, it's actually a very simple idea. Essentially, bonds are formed during chemical reactions to help atoms fill their valence shells. Most atoms do not have full valence shells. And so when atoms fill their valence shells, they become more stable. And this applies to energy differences, okay? Because what we find is that nature favors arrangements in which potential energy is minimized. The lower the potential energy that these atoms have, the more favorable or happy these atoms will be. Well, it turns out that this means that most atoms are less stable by themselves when they have unfilled valence electron shells. But when they form chemical bonds, they form full valence shells. And that chemical bonding will then decrease in potential energy, creating a more stable arrangement of matter. So again, let me summarize this really super quick. The reason why chemical bonds are formed is because atoms by themselves are very high in potential energy. They have unfilled valence electron shells. And so when atoms bond together chemically, they lower their potential energy state as a whole, becoming more stable and completing having full valence electron shells. And that's pretty important. All right. Now, some atoms already have full valence shells, like the noble gases that you see here. I have 3 noble gases: helium, neon, and argon. And I have more or less their electron configuration values. And if I was to highlight the valence electrons here, you would find that in order to form a stable arrangement, the valence shell needs to be full. And so bonds are going to be created in order to fill the valence shell. And we call this a stable octet. So a stable octet. What that means is that there's going to be 8 valence electrons in the valence shell. And when atoms achieve those 8 valence electrons in the outer shell, they become extremely stable with low potential energy. Now, helium is an exception to this. Helium only needs 2 valence electrons because only 2 valence electrons can fit in that first valence shell for helium. So it's okay with those 2. All the other noble gases need to have 8. Because the noble gases have full valence shells or have a stable octet, noble gases are not reactive at all, and they will not form chemical bonds. However, all of the other atoms on the periodic table do not have full valence shells. Therefore, they are going to chemically react with other elements to form bonds to ensure that they get full, stable or full shells in the valence shell, so that they have a stable octet. Okay, and that becomes extremely important. All right. Now, atoms are going to bond in different ways, and depending on what type of elements that are reacting will depend on what type of bond is going to be formed here. So in this class, we're going to look at the three major bond types that occur, and those three major bond types are ionic. Oops, I should use a highlighter. Ionic, covalent, and metallic. And so in the next few lectures down the road here, we are going to look at these three different bond types and how they work and what elements are involved. But for now, this is it for this lecture video. I would advise you to go back and re-look at this. Make sure you study your study guide and take a look at it. So that is it for now.